You know, every single time you go online, there's this hidden world that's watching, collecting, and even trading your personal data. So in this explainer for Chapter 8, we're going to pull back that curtain and really look at online privacy. Understanding all of this is absolutely crucial for your information security exam, so let's break down exactly what you need to know to be totally prepared. Okay, so here's our game plan. We'll kick things off with the online data ecosystem to see who's actually collecting your data. Then we'll dive right into web security threats and, more importantly, the critical web security countermeasures used to stop them. After that, we'll switch gears and look at the risks on your end with browser and mobile vulnerabilities, and we'll wrap up with the essential mobile device protection methods you've got to know for the exam. All right, let's jump into our first section, the online data ecosystem. See, to really get a handle on online privacy, you first have to understand who the main players are, the ones collecting, buying, and selling your personal information, a lot of the time completely behind the scenes.
So first up on our list, we have the data collectors. I'll read the definition in English. Collect information directly from their customers, audience, or other types of users of their services. So what does this actually mean? Well, these are the companies you're interacting with every single day. Think about your social media apps, the online stores you shop at, or the search engine you use. Every like, every search, every single purchase, that's a piece of data they collect. They're really the front line of this whole ecosystem.
Next, we've got the data brokers. Here's the English definition. Compile large amounts of personal data from a number of data collectors and other data brokers without having direct online contact with the individuals. And these are the players you almost never, ever see. They don't talk to you. Instead, they buy up huge amounts of data from thousands of different data collectors, they stitch it all together, and they build these incredibly detailed profiles about you, your habits, your income, your interests, all without you even knowing they exist. And finally, we have the data users. In English, businesses that use collected data for purposes like targeted advertisements, fraud prevention, and credit risk assessment. Okay, so these are the customers of the data brokers. They're the ones who buy those detailed profiles to do things like show you those ads that feel a little too specific, or maybe decide your credit score, or even figure out if you're a risk for insurance. This is where all that data collection turns into real-world decisions that can directly affect you.
And just how far does this go? Well, a U.S. Senate report found some pretty shocking stuff. Data brokers were caught selling lists that specifically identify financially vulnerable people. We're talking about people with bad credit or low incomes. They take your online browsing history and merge it with things like your offline store purchases to build these profiles, all without you ever knowing. This secrecy and the sheer scale of it is exactly why the technical protections we're about to talk about are so incredibly important.
So now that we know who wants your data, let's move into our second section, web security threats. We're going to explore how they get it by looking at the fundamental security problems of the web.
The web is kind of like a perfect storm of security challenges. First off, web servers are designed to be exposed to the entire internet, which makes them a constant target. The software they run is often incredibly complex, which means security flaws can hide in plain sight. And here's the scary part. If an attacker gets into just one server, it can become a launchpad into an entire internal network. And to top it all off, the weakest link is often us, the user, who might not have the training to spot a threat.
For your exam, it's really helpful to think about web security in 3 different layers. First, there's web server security. That's the hardware and the operating system. Second, web application security, which is the actual code that makes a website work. And third, web browser security, which is all on the user's end. We're going to start right at the foundation, the web server.
The number one threat to a web server is right at the operating system level. If an attacker can get privileged access to the OS, we're talking administrator or root access, they basically have the keys to the kingdom. They can steal data, change the website, or use that server to attack other places. Securing this is absolutely fundamental. So how do we defend the OS? For your exam, you have to know these 3 main countermeasures. Think of it like trying to get into a secure building. User authentication is like showing your ID at the front door to prove you are who you say you are. Authorization is the list that says, okay, your ID lets you into these specific rooms. And access control mechanisms are the actual locks on the doors that enforce those rules. You need all 3 to protect the OS.
But it's not enough to just control who gets into the building. We also have to worry about the data itself. The files and the databases stored on that server, that's the real prize for an attacker. That's where all the sensitive customer info, the financial records, and the company secrets are kept.
To protect that data, we have 2 really critical countermeasures. The first one is encryption.
This basically scrambles the data so that even if an attacker manages to steal the file, it's just a bunch of unreadable nonsense without the secret key. The second is using extra access controls directly inside the Database Management System, or DBMS. This lets you get super specific with permissions. For example, you could let a marketing employee read customer names, but completely block them from ever seeing or, say, deleting their credit card numbers.
Okay, so now let's think about threats coming from the network itself. I mean, a web server, by its very nature, is connected to the internet, and that communication channel is a huge pathway for attacks. To defend the network, we start with the usual stuff like firewalls and intrusion detection systems. But a really key strategy for web servers is putting them in what's called a DMZ, or demilitarized zone. Think of it like the lobby in a secure building. It's open to the public, but it's totally separate from the secure offices inside. If a bad guy breaks into the lobby, they're still locked out of the really important areas. But the most crucial thing for web traffic is that we have to use a secure protocol.
And that brings us to a technology that is absolutely crucial for your exam: HTTPS. The English definition is the secure version of HTTP that encrypts all communications between a browser and a website. To put it simply, HTTPS is what creates a private, secure conversation between your browser and a website. You know that little padlock icon you see in your address bar? That's HTTPS at work, and it is the standard for all modern web traffic. Now for the exam, you absolutely must remember the 3 key protections that HTTPS gives you. First, encryption, which stops people from eavesdropping. Second, data integrity, which makes sure the data hasn't been secretly changed on its way to you. And third, authentication, which proves you're connected to the real website and not some fake imposter. One more time: encryption, data integrity, and authentication.
Okay, we've secured the server hardware and the network connection. Now let's focus on the web applications themselves. You know, the custom code that runs on the server to make a website actually do things. And this code, it brings a whole new world of problems.
This right here is the OWASP Top 10 list. OWASP, that's the Open Web Application Security Project. And this list is the industry standard for the most serious risks. Now, you don't need to memorize the entire list, but you do need to understand the ideas. For example, 2 classic attacks you should definitely know are injection and cross-site scripting. With an SQL injection, an attacker could type a malicious database command into a search box and trick the website into just dumping out all of its user data. With cross-site scripting, or XSS, an attacker might post a comment that has malicious code in it, and that code could steal the login information of everyone else who looks at that page.
So how in the world do we defend against these kinds of attacks? The key tool is a web application firewall, or WAF. The definition in English is a firewall that monitors, filters, or blocks data packets as they travel to and from a web application, inspecting traffic based on a rule set. So what does that mean in simple terms? Think of it this way. A normal firewall just checks the address on an envelope. A WAF actually opens the envelope and reads the letter inside to make sure it's not a threat. It understands web traffic on a deep level, which lets it spot and block attacks like SQL injection before they can do any damage.
What's great about WAFs is they're flexible. You can set them up in a few different ways. An organization might use a network-based hardware device to protect their entire network, which is efficient but could be a single point of failure. Or they could use local hardware to protect one supercritical server. Or they could just install local software directly on the server itself, which gives you very detailed protection, but it does use up that server's resources.
All right, we spent a lot of time on the server side of things. Let's totally flip the script now and look at the client side. We're going to focus on the security of the 2 main tools that we all use to get on the web: the web browser and the mobile device.
This is a really important concept. An organization has to treat its employees' web browsers as part of its security defense. That means enforcing policies to keep them constantly updated so they get the latest security patches, using browsers that have built-in protections like sandboxing, and setting them up with high security and privacy settings. But technology is only half the solution. You've got to have continuous user training on safe browsing habits. That's just as critical.
This diagram shows us the entire mobile ecosystem, and it is so important to understand this data flow for your exam. Let's start over here on the far left with the mobile device itself. You can see it has multiple layers: the hardware, the firmware, the operating system, and of course the applications. Now that device connects out through communication networks. This could be public Wi-Fi or the cellular infrastructure. From there, the traffic goes across the internet. In the middle, you see the services it's connecting to. You've got public app stores from Google and Apple, and the device and OS vendor infrastructure for things like software updates and cloud backups. Finally, over on the far right, we have the enterprise systems. This is the company side. It includes private enterprise app stores with approved apps, access and mobility management tools to enforce security, and the actual back-end services the employee needs, like company email and file shares.
Okay, listen up, because this next section is super important for your exam. We are going to take a deep dive into mobile device vulnerabilities and, even more importantly, their specific protection methods. We'll go through the major threats one by one, so pay close attention to these countermeasures.
The first and, well, most obvious threat is just the physical nature of mobile devices. They're small, they're portable, and they are so easily lost, stolen, or tampered with. This is a risk that just doesn't exist in the same way for a giant server that's locked away in a data center.
So the most important point for mitigation is to prepare for the worst. Your security policy has to start with the assumption that any device could be stolen at any time. This means you have to enforce the use of strong passwords or biometrics like a fingerprint or Face ID. And this is critical. You must have remote wipe capabilities to erase all the data from a lost device. And finally, all the data on the device should be protected by full disk encryption.
Mobile devices are meant to be mobile, right? Which means they're constantly connecting to networks the company doesn't control or trust. Think about the public Wi-Fi at a coffee shop or an airport. These untrusted networks are a playground for eavesdropping and man-in-the-middle attacks.
The key countermeasure here is a virtual private network, or VPN. Let me read the English definition. A restricted-use logical computer network that is constructed from the system resources of a relatively public physical network. Okay, so what does that actually mean? In simple terms, a VPN creates a private, encrypted tunnel for all your data that travels over an untrusted public network. Even if an attacker is watching that network, all they're going to see is scrambled, unreadable data.
Another huge risk is just how easy it is for users to install apps. It's totally possible for users to sideload apps from untrusted third-party sources, completely bypassing the security checks of the official app stores. And this creates a major risk of accidentally installing malware that can steal data or take over the entire device.
To fight back against this threat, organizations have to control which applications get installed. The best way to do this is to use a private enterprise app store, where only company-approved and security-checked apps are available. This should be combined with a really clear policy that says no apps from untrusted sources. And that policy needs to be enforced technically using a mobile device management, or MDM, solution.
This one is a little sneaky, but so important. Many mobile devices are set up to automatically synchronize data, like your contacts, documents, and photos, with personal cloud services. While that's convenient, it creates a huge risk. Sensitive company data that's on the device could be automatically copied to an unsecured personal cloud account where the company has zero visibility and zero control.
The solution here is a mix of policy and technology. Organizations have to enforce strict policies that restrict or just flat out disable automatic syncing to personal accounts. And a really powerful technical control for this is containerization. This technology basically creates a separate encrypted work profile or container right on the device. All the corporate data and apps live inside the secure bubble, completely separate from the user's personal stuff, which stops any accidental data leaks.
And that brings us to the end. So let's just reflect on this final question for a moment. Understanding these threats and countermeasures isn't just about passing your exam. It's about being equipped to protect your own digital life in this incredibly connected world we live in. Thinking about where you draw that line for yourself, well, that's the first step toward taking back control of your own online privacy. Good luck with your studies.